Welcome to LabMinutes.com in our lab video series on MPLS. You can find a complete list of MPLS videos on the website by clicking on the link above and sign up for our newsletters to receive the latest video updates. The next PECE routing protocol that we will look at in this video is OSPF. We're going to start off with some OSPF basic configuration. Then we will look at the significance of domain ID and see how that can influence the type of OSPF route that gets advertised to the customer sites. And we will configure a Sham Link and try to understand why you might need a Sham Link between two sites that have a backdoor link. And finally, you will see how the downbit and domain tag can help preventing a route from being re-advertised into the MPLS. For lab physical topology, we have 8 routers, R1 through R8, and one switch 1, with R2, R3, R4, and R5 connected over a serial point-to-point link. And we also have a direct serial point-to-point link between R6 and R7 here as well. And any other connections are pretty much done over a layer 2 VLAN as shown in this diagram. Okay, so for our layer 3 topology, we have a MPLS core at the middle that consists of 5 routers, R1 through R5, with R3 and R5 being a PE-only router, and R1, R2, R4 being a PE router. And we have 4 sites that we're going to be configuring OSPF, or the PECE routing protocol. And just to make a quick note here, the switch 1 is a dual home device that connects to R2 and R4. And we also have a backdoor link that we're going to be testing with between R6 and R7, and that's the directly connected serial interface. So let's get started with our task number 1, OSPF basic configuration. We first need to configure OSPF with corresponding area on R6, R7, R8, and switch 1, which are LCE routers, and then advertise the loopback 10 through 12. Then we need to configure R1, R2, and R4, which are our PE routers, to accept OSPF routes from the VRF-C1 and then advertise them across the MPLS VPN. And we need to make sure the OSPF route matrix does not change by the MPLS VPN, and then we need to verify connectivity between the CE devices and from their loopback 10 through 12. Okay, just to look at the diagram real quick, so we're just going to lay out the basic configuration for each of these sites and then make sure they have a full reachability between one another. Okay, so let's first start on our first CE routers, R6. So let me hop over to R6 right here. First, we need to enable OSPF routing process with the router OSPF. We're just going to pick the process number 1. Then we're going to specify the router ID using its loopback interface. We just want to say 216.0.6, just to show you the interfaces we're dealing with on R6. Here we have our fast00, which connects to R1, and we have the backdoor link, which we'll configure it later in the later task. Then we have our loopback interfaces in 10 through 12, and then the loopback 0. Okay, and then we do a passive default, as always, and then do no passive first of fast00. Then we need to advertise the loopback interfaces. Start with loopback 10, and router R6 is in area 24, so area 24. Then loopback 11, loopback 12, and then the fast00 interface, area 24. Okay, next is router R7. Pretty much the same thing, router OSPF, router ID 0.7. Just to show you right here, loopback interface. And then passive default, no passive, fast00, advertising loopback interfaces, and R7 is also in the area 24, so 24, missing a 0 there, so 24, and then 771, 772, network 27.7, area 24. Okay, next is router R8, OSPF1, router ID .8, no passive. Oh, it's actually passive default, no passive. R8 is using Ethernet 00. Advertising loopback 8801. And R8 is in area 1 for site number 1. Loopback 11, loopback 12, and then the interface IP 18.8. in the area 1. Okay, next we have our switch 1. And switch 1 has two SVI that it used to dual home, which is SVI VLAN 102 and 104. So router OSPF 1, router ID 0.10, passive default, no passive, VLAN 102, 104, and then advertised loopback. Switch 1 is in area 3 for site 3. That's loopback 10, 11, and 12. And then enable it on the VLAN 102, which is 16.102.10, area 3, and then the other SVI you need to enable OSPF on, which is 104. Okay, so at this point we're pretty much done with all the CE devices. We're next going to move on to our first PE device, which is R1, that connects to both R6 and R8. So on router R1, if you do router OSPF, using the same process number 1, if you question mark right here, since we're dealing with VRF, we need to specify VRF at the routing process level. Since the OSPF, there's one routing process per VRF, unlike, for example, EHRP that we looked at in the previous video, we need to get under the same routing process and then specify the address family for a different VRF. But for the OSPF, you need to create a separate routing process for the VRF. So here we're dealing with VRF named C1, and then the rest of the configuration is pretty much the same, which is router ID, we use 0.1, passive default, no passive, and for the router R1, let's look at the interface. Here we have the sub-interface 01.16 and 01.18. So no pass F01.16, and then 18 and 16 connects to R6 and .18 connects to R8. And then we do a network command of those interfaces. 16.1, and R6 is in area 24. And then R8 is in the area 1. Okay, and that's 18.1. You can see we have adjacency to R6 already, and here's adjacency to R8. And we know that R1 is going to have to be learning BGP routes from the other PE routers. It has to advertise those routes to its local site, so we're going to have to redistribute from BGP to OSPF. So let's take care of that right now with the redistribute command. And the BGP AS number we are using is AS100. So BGP 100. And one option you don't want to forget is subnet, so that way you don't only redistribute in a classful manner. So it's specifying subnet, it includes all the individual subnets. Okay, at this point, if you show IP route VRF-C1 and look at OSPF routes, we should be able to see the loopback routes for both R6 and R8. And we can do show IP OSPF VRF-C1 neighbor. Let's see. Show IP OSPF. You can just do show IP OSPF neighbor right here. You can see that we have adjacency to both R6 and R8. And also for R1 to be able to advertise local OSPF routes to the rest of MPLS, we need to redistribute from OSPF to the BGP. So here we're still on R1, do a router BGP 100. Here we have to get under the address family, IPv4, VRF-C1. Let's take a look at what we have right now. Okay, so right here, VRF-C1 looks like from the previous video we have been advertising the local subnet. So let's get rid of that, and we can just advertise those natively using OSPF redistribution, not doing a network command on BGP. So get rid of that, and then we're just going to have to redistribute OSPF process number 1. And since we're not supposed to be messing around with the metrics, we're just going to hit enter right here. And then if you do show IP, BGP, VPN v4, VRF, C1, we should be seeing all the OSPF routes that's been redistributed right here, R6, R8. These are all local route because we can identify them based on the weight value. And we also see the directly connected subnet as well. Okay, so redistribution, it's working. But one thing that you might notice right here is, even though all of our loopback 10 through 12 has the mass of /24, when we advertise the N2 SPF, somehow it came across as /32. And that's pretty much the default behavior of OSPF route advertisements. So if you want the route to maintain the true subnet mask, what we have to do is to get under the interface. So here, let's first deal with router R6. Get under loopback 10, and then we have to change the OSPF network type to a point-to-point. Okay, just enter that, and then going back to R1, do an up arrow. It might take a couple seconds right here. So just took effect. You can see that now the R6 loopback 10 came across with the actual subnet mask, which is a /24. Okay, so let's go around and fix all that. Right, since we're going to have to do that on all of our 4C devices, let me bring up a notepad. The command is going to be the same. So first loopback 10. Let me copy that command. Then 11, 12, copy that and paste. That's R6. Do the same for R7. Since we're going to know that we're going to have to do that eventually. So let's do that now. And then we have our R8, and then switch 1. Okay, give it a couple seconds. You can see all these routes are now coming across as /24. Okay, another thing that I want you to make a note of is the metrics value right here. So you can see that each of these routes has the metrics of 2. If you scroll up, when we look at the routing table, see if we can find that right here, the IGP routing table, we can see that each of these routes coming from OSPF, or being an OSPF route, also has a metrics of 2. So when we distribute from OSPF to BGP, that metrics value is maintained since we did not manipulate the metrics. So now that actual metrics value is going to get carried across in the BGP route, and we will see on the other side once we configure the other PE devices. Alright, so that's pretty much it for R1. Next, let's jump over to R2, and R2 is connected to R7 and switch 1 of the fast00 and fast01. So let's get over to R2. We're going to pretty much repeat what we did on R1. OSPF1 VRF C1, router ID 0.2, passive default, no passive, fast00, and then fast01. For the network command for fast01 is 102.2. And that is facing switch 1, so it should be as part of area 3. And the other one's facing R7, and that should be area 24, and that's 27.2 is the IP on the fast00 interface. Same thing that we need to redistribute the route from BGP to OSPF, so redistribute BGP 100, option subnet. Okay, so adjacency comes up already, so let's do a quick check, make sure we are learning all the OSPF routes from the CE routers. So show IP route VRF C1 OSPF. Okay, so here's our R7 loopback as well as our R10 loopback. Okay, next we'll get under the router BGP process under address family VPN v4 VRF C1. Let's double check what we have. And this guy's also advertising the local subnet, so let's get rid of that. And then we're just going to redistribute fully from OSPF 1. Okay, now do show IP BGP VPN v4 VRF C1. We should now be seeing the local routes, which is R7 and R10, as well as the route that's coming on that R10 switch 1, as well as the route that has been advertised from R1. Right here, you can see you can tell by the next hop 0.1. So those are for R1. With the metrics that's been maintained, so it was being advertised as the metric of 2, and it is coming in as the metric of 2 as well. Okay, so here we have the R6 loopback and the R8 loopbacks and the directly connected subnets on R1. Okay, so now let's drill down into the particular route. Let's pick the 6600 to look at. 6600. And you can see that there's a lot of information here. Again, very similar to what we saw in the EIGRP. And this is because by default, when you distribute from OSPF to the BGP in the MPLS VPN environment, BGP routes or VPN v4 routes actually carry additional information regarding that particular route, and these are the OSPF route components. And you can see it looks kind of cryptic a little bit, but not as bad as the EIGRP if you watch out EIGRP videos. So let's go through this route real quick. So here, just any other VPN v4 routes is being prepended by the route distinguisher from the other side, which is 100:100 to make the route unique. And then it's the actual prefix of the routes. And for the origin, it's incomplete because it was introduced into the BGP by the mean of redistribution. The metric stays as the original metric that was advertised from the other side, which is 2. Everything else just looks like any regular BGP routes. Here, this is where it gets a little more interesting, which is the extended community. Route target is always there, but now we have some of the additional information that gets carried as part of the extended community. And the first thing is OSPF domain. Okay, so let's go through and see what this means. First part is the domain ID type, and the value is 5. And then this strings of number, this first part right here, where it's highlighted, these are known as the domain ID number itself, and by default that's equal to the OSPF process number. And if you remember, we've been using OSPF process number 1, and that's what the number 1 is for. Okay, next if you look at the OSPF RT, okay, the first part, which is a dotted decimal right here, 24 being the area where the route was originated, which was area 24, and this is where you can see right here, since there are 6 loopbacks, it was originated in area 24, and you can see the value 24 right here. This 2 is the LSA number, so we're dealing with LSA 2. So this way the egress PE router knows exactly what type of LSA is supposed to be. And then we also have the router ID, where the route is being received from. And obviously we also have the MPLS label that comes across the route. Okay, so with this information, the router R2 knows exactly how to put that route together and advertise that to the local subnet. Okay, so that's the configuration for R2. Now let's take care of our last PE router, which is R4. So let's hop over to R4. Okay, router OSPF1 VRFC1 with the router ID of 1604. Passive default, no passive, and let's see, R4 we're only dealing with fast 00 that connects to switch 1, so that would be fast 00. Network command 104.4, area number 3. Okay, and I'm going to redistribute from BGP 100 with the subnet option. Okay, so let's do a quick show IP route VRF C1 OSPF. And CR4 is learning switch 1 loopbacks. Now getting under the router BGP 100, address family VPN v4, VRF C1. See what we have one more time. Here we have that network command that we might want to remove. Otherwise it will show up, since it will be originated as the BGP route, it will show up an external route, so we don't want that. So let's remove that, and then instead we're going to redistribute from OSPF 1. Okay, so do a show IP BGP VPN v4 VRF C1, and here R4 has been learning all of the routes. So R6, R7, R8, switch 1, and then the rest of the PEC subnets. Okay, so at this point, all of our PE routers should have received each other's routes and then redistribute them to the CE devices. So let's verify our connectivity, starting off at the router R6. Let's do a show IP route OSPF. Okay, so here immediately one thing that you notice is these routes is coming across as the IA, or IA being the inter-area routes, which is LSA 3. But like we saw earlier, we would look at the specific BGP routes, although there's information regarding the LSA itself, and it's coming across as 2. So let's take another look at the router R1 in this case. Show IP BGP VPN v4 VRFC1. That should be 7700. You can see right here, although the route has been marked as LSA2, any route that's being redistributed from BGP as it comes across the VPN to the local OSPF, by default, the route will be advertised as the type 3, which is the summary type, and that's just the default behavior, and this is because the MPLS itself is being treated as the area 0, also known as a OSPF super backbone area. So just like any other routes in the regular OSPF, when it has to go through, originate from one area and then go through the backbone area and then advertise to a totally different area, the route comes across as the LSA type. Okay, so this is exactly what's happening here. And that may or may not matters to you, but you see in the later task that we're going to be dealing with the backdoor link, it will become important, since we'll see how, and we'll see why that is the case. Okay, but for now, you can see that all these routes coming across as a LSA3, and you can see that by do show SPF database, you can see all these routes are listed under a summary of LSA3. Let's do a quick check on R7 as well, so show IP route OSPF. You can see all these routes coming across as the inter-area routes as well. Okay, so let's do a quick connectivity check. I already have a Tcl script for this, so let me just copy and paste that, and we're just going to check between a loopback 10 to a loopback 10 between the CE routers. You can see we can ping, in this case from R6, you can ping R7, R8, and switch one loopback 10, sourcing from its own loopback 10. Okay, we can do same thing with R7. Okay, and we also get all the other successful pings from R7. Then we can do a quick check on R8, ping 6601, 7701, and then 101001. Okay, so we have verified reachability between all of these 4 sites, and that should complete right here our task number 1.